Okay, so today we're going to talk about creating a table of values for a function, and we'll see some where we create a table of values in something that's not a function. General idea for the next couple of days is a quick refresher on inputs and outputs. So we're going to focus on tables for today. We'll build in inputs and outputs and see that function notation again with graphs tomorrow. But on page 3, I just want to go through really quickly a refresher on table of values. Okay, so for the first couple of examples, I have your table set up for you. We're going to write a table of values based on the function that we're given. So this just means that we are plugging in these x values for x in our function, which is what we did yesterday, right? The format was a little bit different because I gave you function notation. I said, here's your function, find f of 3, find f of -1. This is the same idea, okay? Just the format's a little bit different. So if I ask you to create a table of values for my function here, for example 1, that just means you are going to plug in these values for x. And for these first couple of examples to get you started, I've specified those x values. We'll see a couple of examples later on where you get to pick the x values that you're going to plug in. But for the first few, I've given them to you. So this is just 3 times -2 minus 2. Be careful with your simplification, just like yesterday. So this would be -8. And then I do the same thing for my next value. I know you guys have done this before. The reason that I wanted to do a little refresher on this was because when we get to our graphing unit and we're looking at all different types of functions, if I remember what a parent function looks like for the example that I have, awesome. If I look at this and say, oh, that's a linear function, I know it should look like a straight line. Its slope is positive, so it's going to look like this. It's got a y-intercept here. If you remember that from your parent function, awesome, you're off to the races. If you don't remember that, or you're encountering a function you've never seen before, a table of values is a good way to get a handful of points so I can start to get an idea for what that graph should look like. Okay, so we're setting that up now so that we have this as a tool to be able to use later on. Okay, and then I'm going to keep plugging in my values here. Plug in 0, and I would get -2. If we plug in 1, this would be 3 minus 2, which is 1. And if I plug in +2, I would get 6 minus 2, which is 4. Table of values. So if I wanted to graph this function, now I have a set of points that I can plot to be able to see what that graph should look like. Is this function going to be increasing or decreasing? It's a question that I asked you last year in Algebra 1 when we were talking about graphs. Okay. How do I know if a graph, if I'm looking at it, if it's increasing or decreasing? I've got a picture, a graph in front of me. Increasing means it goes up, right, from left to right. Decreasing means it goes down, right? So increasing looks something like this. Decreasing looks something like this. So if I had the graph, pretty easy to tell. What if I have a table instead? What should I look at? The values, right? Which values? The y values, right? Those function values, okay? Yeah, which is the right side of this table. But yeah, that's what I'm looking at. I'm looking at those y values. So my y values here, as my x, right? My x's are in order. So as my x goes up, what's my y value doing? Also going up. So we're increasing. That's an idea, again, we talked about with graphs, but we can get there from a table of values as well. Okay, I know that this function is increasing because those y values are increasing. Let's take a look at example 2 here. Another function. I want to create a table of values to represent this function. It's a different type of function than what we saw for example 1, but I treat it the same way. Okay, So again, for this first one, I've selected some x values for you. I'm going to plug them in and see what we get for y. So this would be negative, in parentheses, -2 minus 1 squared plus 4. Follow order of operations when you're simplifying. Be careful here. This would be -3. -3 squared is 9. So we have -9 plus 4. That gives us -5. For -1, same idea. We're plugging that value in for x and simplifying. Again, make sure you follow order of operations. So this would be -2. -2 squared is 4. So we've got -4 plus 4. That's 0. We plug in 0. In parentheses, we get -1. Square that, we get +1. So -1 plus 4 gives me 3. And then I plug in my next value. This time we get 0. 0 squared is 0. Plus 4 is 4. And then we plug in 2. 2 minus 1 is 1. 1 squared is 1. -1 plus 4 is 3. Different function, same idea. Now, I said a minute ago, it doesn't matter that it's a different type of function. But one thing that we might notice if we remember features of a quadratic function is that I've got some y values that repeat in here. Okay? Does anybody remember the shape of a quadratic function? Is it a like straight line? Is it curvy? It's U-shaped, right? It looks like this, or sometimes upside down, right? It looks either like a bowl of cereal or an umbrella, right? And then we had a special name for that point in between those repeating values. Does anybody remember the name of that special point? The vertex, yeah. So if we remember some of these key features from our parent functions, we could maybe fill out our table a little faster, maybe have a little bit better idea of what we're seeing when we look at that table of values. So we'll drag back all that stuff that we've seen before as well. And then this is a little review from yesterday. What's f of 0? This time, though, I've got a whole table of values already. Yesterday, when I asked you what's f of 0, what's f of 2, we had to take that and plug it into our function. If I've got a table of values, I already know that. Okay, I already know what f of 0 is. I can just go to where x is 0 and report that y. F of 0 is 3. I don't have to plug it in again. We've already done that. And then the opposite is true as well. If I ask you an output and we have a table, you can give me the input that matches. So here's a y value. I want to know what's the x. So if my y, my output is 4, what x did it come from? 1. These are ideas that we worked on in Algebra 1. We're reviewing, refreshing. We're going to reuse those ideas again in Algebra 2. Question for me so far? Okay, let's take a look at example 3. Example 3, we've got another function here, and I filled out most of the x values for you this time. Let's go ahead and plug in what we've got already. So if I plug in x equals 0, that would be the square root of 0 minus 4. So I have the square root of -4. We talked about square roots of negatives yesterday. Not real, right? This is going to be something that is not real. I don't know what it is right now, but I know it's not going to be something that I could plot for a graph. So that's not a very helpful x value. Let's plug in 1. This would be the square root of 1 minus 4, which is the square root of -3. Do we know the square root of -3? I just know it's not real, right? I know it doesn't help me for my table of values. Okay. So let's pause really quickly and talk about why some of our x values are not working for this function. Okay. For a square root function, I need to make sure I'm taking the square root of a positive number. Otherwise, I get stuff that's not real, right? We don't know how to handle these things. I can't graph things that aren't real, values that aren't real. Okay, so I need to be careful when I'm making a table with what values are okay for my input and what kind of values I can expect for my output. Okay, so I have a problem here because the square root of a negative number is not a real number. Especially if we're using our table to graph, I can't plot numbers that aren't real numbers on a coordinate plane. Let's keep going here with 4 and 5. See if we have the same issue or if we're okay. So this would be 4 minus 4. So the square root of 0. Do we know the square root of 0? Is this something I can evaluate? 0. Square root of 0 is 0. We can do square root of 0. If I plug in 5 for x, the square root of 5 minus 4, so that'd be the square root of 1. Square root of 1 is 1. That one's okay. Now we're going to pick a value to plug in for x for my last line in my table here. Now here's the thing. You told me 8. Okay, you're already ready to rock and roll with 8. Why did you pick 8 and not 6? Yeah, here's the thing that we want to think about is, could I plug in 6 here? Sure. If I choose to plug in 6, I would have the square root of 6 minus 4. So I've got the square root of 2. And there's nothing wrong with the square root of 2. It is a perfectly fine number. But if I'm using this table to graph, is that an easy number to plot? Not so much, right? It's not a whole number for sure. It's going to be some sort of decimal. Off the top of my head, I don't know exactly what that decimal would be. I don't have a very precise approximation of it. So instead of using a value for x that's going to give me the square root of 2, we can select a value for x that's going to give me something a little bit friendlier, especially when we're using our tables to be able to construct a graph. So I heard 8. What might be another good option, friendly option for x? Might be something else nice to plug in for x. $13 would be another good one, yeah. So if I plug in 8, that'd be the square root of 8 minus 4. So the square root of 4, square root of 4 is 2. If we plug in 13, the square root of 13 minus 4, that'd be the square root of 9. Square root of 9 is 3. Okay, so it's okay to skip some x values, even if there's nothing wrong with plugging in 6 or 9 or 10 or 11 or 12. It's okay to jump around if it makes your work a little bit easier. Okay. Let's talk now about another value that we could have possibly plugged in, but we skipped. So nobody told me I should plug in 7. So let's plug in 7 and see what happens. Okay. So if I find f of 7, I'm going to plug in 7 for x. This would be the square root of 7 minus 4. So that's the square root of 3. If I'm talking about graphing, I'm in kind of the same boat that I was in up here with the square root of 2, right? That's not going to be a nice value to plot. That's okay. I just asked you to find f of 7. I didn't ask you to graph it. The square root of 3 is what we would call an exact answer. I could, if I wanted to, type that into my calculator and get a decimal rounded to 2 or 3 or 15 places. But square root of 3 is what we would call an exact answer. When we are solving for some of the other things that we'll do in Algebra 2, I'm going to ask you to give me exact answers. But there will also be times where an exact answer isn't very helpful. If, let's say, this were a problem where my output values all gave me a time, 1 minute, 2 minutes, 3 minutes, square root of 3 minutes. Is that like a helpful way to phrase time? Yeah, if I tell you watch the clock for square root of 3 minutes, that's not helpful at all. So one thing we want to be able to do is to give reasonable approximation. Our calculator can help us with that. But I also want to work on some number sense this year when we come to values that aren't nice whole numbers, okay? So we know that the square root of 1 gives us a nice value, right? The square root of 1 is 1. I know that the square root of 4 gives us a nice value. The square root of 4 is 2. I know that the square root of 3 is between these guys, right? The square root of 3 lands in here somewhere, between square root of 1 and square root of 4. What that tells me then is that whatever the square root of 3 is equal to should be somewhere between 1 and 2. Does that make sense? I know the square root of 1, which is smaller than this. I know the square root of 4, which is bigger than this. So whatever this guy is, has to be between 1 and 2. I also know that it should be closer to one of them. Is it going to be closer to 1 or closer to 2? Closer to 2, right? Because this value is closer to this value. So it's approximately between 1 and 2, but closer to 2. So 1.75 would be a better approximation than 1.4. I want something closer to 2. Questions for me so far? Okay, turn the page for me. For our next example, we're going to make a table again, but this time I'm not giving you a function to start with. So for example, 4 says a colony of bacteria has an initial population of 3 and doubles every hour. We want to create a table of values that shows the population growth over a period of time. So I've got your sort of tops of your table labeled for you, but I didn't put any values in on this one. Okay, we're going to decide that on our own. I know that my population starts at 3, so it's probably a good idea to start my population at 3 in my table. What would be the time that I would write to correspond with that? 0, very good. Yeah. And now it tells me that our population doubles every hour. So how do you think we want to count our time? What kind of values do you think we want to use for the time? Probably whole numbers, right? 1, 2, 3, right? Now, could I check the population of this colony every half hour? Could I do that? Sure. Could I check it every 20 minutes? Sure. Could I check it every 18 seconds if I wanted to? Sure. So could I use things besides whole numbers in here? Yeah. Is that going to be an easy thing to do based on the information that we have? No. And this doesn't need to be any more complicated than using whole numbers. I just wanted to talk about values that would be okay. So let's check every hour. And now I don't have a function this time. I didn't give you a function to describe this. I just described to you in words how this population is changing. So I'm not plugging 1 in anywhere. I don't have a place to plug in 2. I don't have a place to plug in 3. Instead, we're going to use what we learned here, that our population doubles every hour. So after 1 hour, what will my population be? 6. In another hour? 12. In another hour? 24. In another hour? 48. No function this time, but we're still able to construct a table based on what we knew. So a couple of questions about this. A, we already answered. What types of input values make sense for this problem? We talked about whole numbers would be easiest, but I could do fractions or decimals. Could I do negative values? Would negatives make sense here? No. So I want to stick with positives. Positive values here. Whole numbers are nice, but anything would work. And then how about output? What types of values will I get from my population? Well, we're seeing multiples of 3 because of the inputs we picked. What if I picked in 20 minutes? Would it have to be a multiple of 3 if I checked in 20 minutes? No. So it's a good thought, and that's a good observation from our table. These are all positive numbers. Do they have to be positive numbers? Yeah. These are all whole numbers. Do they have to be whole numbers? This time, yes, they do, right? Because we're talking about bacteria. That's what we're counting here. So those are going to have to be whole numbers. So for our output, we need positive whole numbers. And there's one more thing that's going to be true as we check on our colony here of bacteria. That number is, it's got a minimum. It's got a lower bound. Yeah, it's always going to be bigger than 3 because our population is growing and we started with 3. These have to be whole numbers greater than or equal to 3. And then our last couple here, I'm asking you some questions based on the information we put in our table. How many bacteria are present after 3 hours? 24. What I'm asking you here, I could have also asked you with function notation, and there's a problem a little bit later where I ask something similar with function notation. We don't have a function this time. We've got a table to represent our function. That's okay. 3 hours, we've got 24 bacteria. For D, give a reasonable estimate for how long it will take the bacteria population to reach 20. So at some point, can I expect that I could have 20 bacteria? Sure. Do we see that time in our table? I see 12 and I see 24. 12 is too small, 24 is a little too big, okay? But I can use this information to come up with a reasonable time estimate for when I would get to 20. Somebody want to give me a reasonable estimate? It would be between here and here. Between 2 and 3, right? Closer to 2, closer to 3. Why closer to 3? Yeah, because I'm looking at these values and I'm deciding which of them is closer to the one that I want, closer to 20, right? So between 2 and 3, but closer to 3. And then last one, for example 4, find and interpret f of 2 in the context of the problem. So there's some function notation like what we saw yesterday, f of 2, okay? From a table this time instead of a function, what is f of 2? 12, right? When my x value is 2, my y value, my output is 12. And then what does it mean in the context of the problem? We did that a lot in Algebra 1. We're going to continue to do that in Algebra 2, okay, in the context of the problem. Those of you that had me for Algebra 1, when we saw questions like this, I told you that when I asked you to interpret in the context of the problem, I want you to tell me what are the labels that go with these numbers, okay? Piece together that story. Perfect. After 2 hours, there are 12 bacteria. So what are the labels that go with this? 2 what? 2 hours. 12 what? 12 bacteria. So after 2 hours, There are 12 bacteria. Very good. Not too bad. Last thing for today, turn the page for me. I have 2 more functions here and 2 more tables, but this time I have not filled in any X values for you. Okay, so I want you to create that input output table for me. I want you to fill the table, so I want something in each line. Okay, different value, different sort of set of values in each line of your table. Before I turn you loose though, I want to talk about what kind of X's it's okay to pick. Okay, because we saw for our square root function, some of those X values were not okay. They didn't give me output values. So for example, 5, x cubed plus 4x minus 3. Are there any X values that I cannot plug in here? Am I going to have any problems? No. So one thing I want you to think to yourself is, can I plug in positive numbers? Sure. Could I plug in negative numbers here? Yep. Could I plug in 0? Yep. Could I plug in a fraction or a decimal? Yeah. Do you have to plug in a fraction or a decimal? No. Okay. You can plug in whatever values you would like. Pick things that are going to be easier for you to work with, but you can plug in anything for X here. And then the same thing for number 6. Could I plug in positive numbers? Could I plug in negative numbers, fractions, decimals? Okay. So I want you to go ahead and make your tables, for example, 5 and 6 as your last thing for today.